Hi everybody and welcome to the 17th chapter in your Java EE 7 tutorial series. In this tutorial we'll be talking about JST or Java Servlet technology, which is a dynamic, user-oriented way of contenting web applications and using a request-response programming model. So before we get any further, what is a servlet? It is used to extend the capabilities of servers that host applications accessed by the means of a request-response programming model. Every servlet needs to implement the servlet interface to make use of the functions that handle requests and responses. Now let's take a look at its lifecycle. The servlet is first initialized if it hasn't been already through the init, and then it processes the client's request using the service. Servlet is terminated using the destroy method, and then finally the servlet is garbage collected using by the JVM, and the cycle repeats on and on. Now, we can take a look at how to handle these servlet lifecycle events. There may be times you want to monitor or react to lifecycle events. Here, you can use listeners that fire when certain lifecycle events occur. Classes annotated with the @WebListener must implement one listener in this list. In this example over here, we can see that it's used this attribute listener, context listener, and the web listener, and you have the annotation called web listener with no parameters, and you create your class called simple servlet listener. Now let's take a look at how to create and initialize a servlet. You can use the annotation @WebServlet to define a class as a servlet and contain metadata inside the URL. Over here, you will see that we have the @WebServlet, and inside the over here, you can see that it specifies the URL for which this servlet is run on. Then there's writing service methods, which first you can retrieve an output stream from the purpose, fill in the response headers, and write any body content to the output stream. Now to get information from requests, all you got to do is put in, you've seen this format before, you've seen HTTP, your host, which in this case would be our local host, the port, which in our case is 8080, request path, and you can put any query that you want in this right after the question mark. To construct responses, it has to contain data passed between a server and the client. Now to filter requests and responses, you can use filters that can query, block, or modify the data passed through it. The applications of filters include authentication, logging, image conversion, data compression, and encryption. To program a filter, you got to define a filter in a web application by using the @filter annotation. Like the web servlet, it also needs to specify the URL. The init params attribute is used to configure data to the filter, which means that whatever stuff is inside here, this will be used, the filter will be put on top of it. And the most important methods of filter are init, doFilter, and destroy. Now to specify filter mappings, a web container uses filter mappings to apply filters to web resources. They use the filter's URL that was specified in the annotation @WebFilter. So in this case, in this case, you can see that our filter is kept on these three servlets. This filter is kept on only the servlet 2, and this filter is kept on these two servlets. That's how filter works. And now let's go to invoking web resources. Web components can invoke other web resources either directly or indirectly. Indirectly means embedding a URL that points to another web component in the content returned to a client. And directly is either including the content of another resource or forwarding a request to another resource. Sometimes you may want to transfer the control of the request to another web component when the current component is done with it. Here you would use the forward method of the request dispatcher. This sends the request to another web component and lets it deal with the response. Over here, you'll see that the indirect way is to send an embedded URL and it will go to here. And directly is going to a different service without telling your client that you're going to that service. Now, one thing that you want to remember when doing stuff is you have to understand that HTTP is stateless, which means that when a request is made, a response is sent and no data corresponds to that response. This makes requests that are connected together difficult to use together, and web-based applications are responsible for maintaining such a state, which we can use as a session. So accessing a session. Sessions are represented by the HTTP session object. You can access a session by calling the getSession method of a request object, which returns a session object or creates one first. Then there's session management. Because the HTTP client has no way to signal that it no longer needs a session, each session has a timeout so that its resources can be reclaimed. Now, let's take a look at finalizing a servlet. A web container may decide to finalize a servlet, which means that it should stop its servicing and return the resources it has used back to the web container. This may cause problems if there are still services running and are still not finished. This chapter explains the following of keeping track of the threads that are being used by the service method, providing clean shutdown by letting the threads running know about the shutdown, and have the long-running thread to periodically check for a shutdown, which will make them finish and clean up. And in this example, this is one of the few times it's actually appropriate to override the service method, or else you'll just use like do get or do post. But here, let's use the service method, and it's used to preserve the functionality of the original service method. Now, to notify methods to shut down. To ensure a clean shutdown, two of these things should happen. You should first check if there are any running services through the service counter, and tell any outstanding threads that a shutdown has been called. In this example over here, you can see that this destroy method utilizes these methods. First, it checks to whether there are still service methods running, and if there are, it will tell them to stop, and it waits for the service methods to stop. Now let's take a look at creating polite long-running methods. You may want long-running threads to periodically check for a shutdown while its service is running so it can appropriately stop their work. In this case, you can see that if there's lots of stuff to do and it's not shut down, it will check if it's part of a long-running operation. And if not, it won't run it. But in this case, if it is, then it will check periodically if it needs to shut down. Now, in the recent years, uploading files has become a common requirement for many web applications. In prior versions of the servlet specification, you had to use external libraries and complex input processing. Now, JST comes with file uploading straight out of the box, with multi-part config annotations. First, you'll see here is our location, which tells us where the file will be temporarily stored, our file size threshold, which tells us the file size after which the file will be briefly stored onto the disk in bytes, our maximum file upload size, and our maximum size allowed for multi-part / form data request. Then there's also the hard-coded way where you can also set the location and such inside your configuration file. Now let's take a look at another sweet thing that JST has, asynchronous processing. Web containers usually have specified threads reserved for client requests. These threads run mostly well on their own, but they may not do the best and most efficient way to complete work. They may sit idle when waiting for a resource to become available or an event to run. These scenarios are called blocking operations that limit the scalability of the web application. Asynchronous processing refers to assigning these blocking operations to a new thread and returning the thread associated with the request immediately to the container. It is the equivalence of having someone else stand in line for you while you shop around. So this asynchronous processing in servlets is done by doing the async context, a context equals request.start async. So to enable asynchronous processing on a servlet, you set the parameter async supported to true, which you can see over here. And you can then use the async supported, that inside your methods. This call puts the request into an asynchronous mode and ensures that the response is not committed after exiting the service method. Now let's take a look at the following code. This shows a basic servlet that does not use asynchronous processing. And with asynchronous async servlet, it adds async supported equals true to the @web servlet annotation. The rest of the differences are inside the service method. And the service method of the async servlet returns immediately, and the request process in the asynchronous context. Now let's take a look at non-blocking IO. Although asynchronous processing negates blocking operations inside your service methods, threads can still sit idle due to input and output considerations. An example of this, a client could send a very, very large HTTP request, but the client has a very slow internet and a request takes much longer than expected. The issue here is that the container has a thread waiting for the request. This is the equivalent of a waiter standing in front of the oven waiting for the cake to bake. This is a huge waste of the waiter's time, who could be receiving more orders, and the customer's time, who could be waiting for another person's large dinner while all they want is a glass of water. Non-blocking IO helps solve this problem. So, reading a large HTTP post request using non-blocking IO. In this example over here, I know it's a lot, but let's just go through it real quickly. So it first declares that it's an asynchronous service using this async supported equals true. Then the service method puts the request in asynchronous mode, which is required for non-blocking IO. Then the service method, which you can see over here, the service method obtains an input stream associated with the request and assigns a read listener defined as an inner class. The listener reads parts of the request as they become available, and then writes some response to the client when it finishes reading the request. So next, one cool thing about JST is there's protocol upgrade processing. There may be reasons to switch from the default protocol HTTP that we've been using and we know and love, but sometimes you may want to use something like WebSocket or TCP. Whatever the reason may be, JEE has a way for you to change. In HTTP 1.1, clients can request to switch to another protocol using the upgrade header field. Once the protocol is switched, the client and the server will use the new protocol. Over here, you can see that you can use the upgrade XYZP, and it will tell you that it will be switching protocols. Once it switched protocols, and in this code, it demonstrates how to accept an HTTP protocol upgrade request from a client. And you can see that setting the status to 101 tells the client that it's switching protocols. And once you've switched it, this XYZP upgrade handler class handles the connection. But so it's once you switch from HTTP to this protocol over here, this will handle all your streams for the later on. Of the lifecycle. So now that you learned all of that, let's take a look at the mood example application. So now that we're in our NetBeans, let's go ahead and open our project and let's go back. Go to our, let's see, web, servlet and mood, and go ahead and open that project up. And this example just shows Duke's mood depending on the time of day. It also shows how to develop a simple application by using the @WebServlet, @WebFilter, and @WebListener annotations to create a servlet, listener, and a filter. So the mood example is comprised of 3 components. So there's the mood servlet, which is over here. Mood servlet. There is the time of day filter, so over here, and the simple servlet listener. So the mood servlet is our presentation layer. This is the thing that you will be looking at the first thing in here. You will see that it's all in Java code, which is not really conventional. You don't want to be putting HTML code using Java code, but it works. There is the time of day filter, which is our filter. Actually, let's go back to that servlet. Let's see that our annotation of web servlet, and it has /report, which means that in our URL, you will see /report when we're using this servlet. In our time of day filter, you can see the @WebFilter telling us that this is our filter, and it says filter name time of day. And the URL pattern is on everything. The star means that it's on everything. This filter is on everything. And what this filter does is it sets the mood depending on the time of day. it checks whether the hour is between 11 o'clock to 6 in the morning, and it says Duke is sleepy. If it's from 7, 13, or 18, he's hungry, and from here to here, he's alert, and so on and so on. Finally, there's a simple servlet listener, which logs any changes in the servlet's lifecycle. And this logs will be found right over here in our output tab. If you don't have it up, just see the output over here, click on that, and you will see it over here. So now that you got that, let's go ahead and run our Glassfish server and go ahead and start it. And once that's done, let's go ahead, right click and click build. And once it's finished building, let's go ahead to our Google Chrome and put in this URL. Go ahead and put that. And you will get that Duke is pretty thoughtful right now. You can see that the time is from 7 p.m. to 8 p.m. And we can go back to our code and let's see what time of day that would be. So over here, it would be 7. So of course, 7 p.m. in the evening. So that would be 19. So 19, it says he is thoughtful right now. And that is that example right there. Now that we're finished with our mood example application, let's look at another example of file uploading. Okay, so you know the drill. Let's go ahead and clean it. And let's close this guy. Open up our project and you will see our file upload over here. Go ahead and open that up. And this file upload example shows how to implement and use the file upload feature. The first thing that I want to see over here is our index.xhtml. And one thing that I want to take your notice of is this method equals post. What this tells us is that it wants to use a post method instead of a get method, which is usually it's the default. It's because it wants to send data to the server as part of the request. In contrast, a get method sends a URL and only headers to the server. So now that you got that, let's go ahead to our file upload server, which you can see inside our server packages, and double clicking that. So over here, you can see our @web servlet, and you can see that the URL pattern is only on the /upload. And there is another annotation called multipart config, which indicates that the servlet expects requests to be made using the multipart /form data mime type. That means that this data type is basically like it's just expected, and we don't want our code to basically break if we're sent to this kind of type. So once again, let's go ahead to our servers, right click, mine is already started, our Glassfish server, and go ahead and click build. Once our build is done, let's go to our Chrome and put in this URL, our localhost 8080 file upload. So over here, you can see that we can choose a file where we can go to our computer. Let's say choose file, and you can pick whatever you want inside your computer. And you can put a destination where you would like to put it, and you can click upload. And of course I didn't put anything, so and the access is denied. But you can try ahead and go ahead and try to use this out. It's pretty cool how you can upload files and put it to your server. Now that you get how to upload files, let's finally look at this Duke ETF example. Back in our NetBeans, let's open our project and click Duke ETF. So this demonstrates how to use asynchronous processing in a servlet to provide data updates to web clients. This example resembles an ETF, or an electronically traded fund. The first thing that I want to take your attention onto is our Duke ETF servlet. Now this servlet puts requests in asynchronous mode, which you can see over here, async supported equals true. And it stores them into a queue and writes the responses when a new data for price and trading volume becomes available. Then there's the enterprise bean over here, which updates the price and volume information every second. And finally, there is the HTML main.xhtml. So over here, this is actually using Ajax. It's using Ajax to basically change a little part of the web page. This is talked in more detail in my previous tutorials, so check that out. But just know that there's just a small part of the web page that is reloading constantly. Okay, so to start this example, let's go ahead and start our Glassfish server. It started for me, and let's build it. It has started, and let's go to our Chrome and put in our URL. Paste it over there. And you can see that the price and the volume is changing constantly, but the page is not reloading. This is thanks to our friend Ajax, which I've again talked in the previous chapters, but this part is reloading, and it's constantly checking the price and checking the volume. What's cool is that you can actually take this and make a new browser and go ahead and put it in, and your price will be the exact same. Of course, there's a little delay, but like they will be the exact same because they're on the same scope. And that wraps it up for today's tutorial. Man, today's was a really long one, but I guess you understand now why Java Servlet technology is so amazing, about how its dynamic user-oriented content in web applications and its use of request and response programming model is so useful even today. And with that knowledge, I'll see you in the next video.